measures for the nuclear uh, energy, like nuclear fuel cycle, nuclear fuel reprocessing, safety, and nuclear waste management. And then we will discuss about the hydropower, like basics and the technological aspect of the hydropower, hydro potential and hydropower exploitation in Indian scenario, major hydroelectric power plants in India, components of hydroelectric power plants, like how the water is intake channelized uh, through the turbine to produce the hydroelectricity, desilting. Okay, what is spillway, what is penstock, what is turbine, and how the generator and governor work to produce the hydroelectricity. Okay, then we will discuss about the energy and climate change linkages, in which we will focus on the two aspects, like the environmental issues and constraints and problems with future perspectives. And then we will also discuss the energy and carbon emission, international responses to the climate change, like the body which is formed for you know discussing and making policy and frameworks and giving direction to the global best practices. Okay, and one of the body is UNFCCC. Okay, and there have been also some frameworks in the terms of SDG to have a better and clean energy usage. Okay, and how to tackle the climate change. Okay, and then energy with a perspective of accessibility, affordability, reliability, and sustainability. Thank you.
इसी में कर देंगे ना, एडिटिंग ज़्यादा हो जाएगी.
Hello everyone, I welcome you all to the Energy and Environmental Implications course ENR 147. So, in part 1 of the module 1, which is coal, oil, and natural gas, we will discuss the overview of energy sector with a global and Indian context. So, uh, with the data which on the global energy mix in 2024, fossil fuel having the highest share, like 78% in mm, the total global energy consumption. Okay, and renewable energy sources like biomass, uh, wind having about only 12%, and then followed by nuclear 8% and hydro 2%. Okay, however, in 2024, with a perspective of 2023, the percentage increase or growth in the fossil fuel usage is lesser than the other energy sources. Like fossil fuel usage have increased 1.5%. However, the renewable energy sources have increased uh, at a rate of 5.8%, nuclear energy usage increased at a rate of 3.9%, and hydropower utilization increased at a rate of 4.4%. So this shows actually the decrease in the fossil fuel usage, decrease in the growth of the fossil fuel usage rather than in the global energy mix. Similarly, coming to the Indian context, currently coal have a share of about 72% in Indian energy mix, and followed by renewable sources 21%, and hydropower is 9%, and nuclear is 3%. And coal is the largest source of energy. In 2024, about 1400 terawatt hour of energy was produced using coal, and renewable was having about 410 terawatt, hydropower was about 175 terawatt, and the nuclear was almost 58 terawatt hour of power was derived. Okay. However, with a push to the higher renewable energy sources, the projected energy mix in 2030 for India is like the coal will be having the highest share, but its share will be coming down drastically from 72% to 45%, and the share of the renewable energy sources will increase from 21 to 40%. Hydropower and nuclear power is also expected to have a considerable share in Indian energy mix. But in the 2050 scenario, the projected energy mix portray a very different scenario for the energy in the terms of sources. Okay, it is expected that the renewable energy sources will constitute about 60%. Okay, and coal will be having about 20% share in Indian energy scenario, and hydro and nuclear will be having 10% each. Okay, given to the context of the global and Indian trends in 2024, energy demand increased globally with a at a rate of 2.2%. However, in India, the energy demand increased at a rate of 8.7%. Okay, and the coal share in the global energy trends was like 26%, and in India, it was about 72%. And the renewable energy sources in India was about 21%, and globally it was about 30%. And per capita energy consumption in India still remains the lower than the global average, which is about 3200 kilowatt hour, but in India about 1255 kilowatt hour was the per capita consumption. Okay, now coming to the part 2, which is coal. So the coal is mostly characterized in the four type: the peat coal, lignite coal, bituminous coal, and anthracite coal. The anthracite coal is considered as the highest quality coal, in which the carbon content is very high. Bituminous coal is second to the anthracite coal, which is somewhat lower in carbon content than the anthracite, and the peat coal is having the lowest carbon content, and this coal is rarely used as a fuel. Okay, and for the power generation, mostly lignite coal is used, and for the metallurgical purpose, anthracite coal is used. Okay, in India, uh, and there are about 352 billion tons of the coal reserve is estimated to have, and about 170 billion tons of coal reserve is proven in India. Okay, so Indian share is about 10% in the global reserves, and Jharkhand, Odisha, and Chhattisgarh are the notable locations for the coal mines in India, and the lignite coal in India is mostly found in the Tamil Nadu region. Okay. Comparing with the global context, about 1100 billion tons of coal reserve is proven to be in the world, out of which 250 billion tons of coal reserve is estimated to be in US. Russia is having about 160 billion tons of coal reserve, and Australia is having 150 billion tons of coal reserve. Okay. So in this context, USA is having the highest coal reserve in the world with 23%, Russia is having 15%, and Australia is having 14%. With comparison to India, India is having just 10% of the coal reserve. Okay. Now coming to the coal production import in India. In year 2023-2024, Indian domestic coal production was about more than 1,000 metric ton, out of which 265 million tons of coal was imported, and coking coal about 60 million tons was imported. Okay, and the non-coking coal was 25 million tons. So in India, coal quality, varied drastically. Okay, mostly bituminous coal is found in India and in the mines of the Jharkhand, Odisha, and Chhattisgarh. And lignite coal is mostly found in the Tamil Nadu region in India. Okay. However, the lignite coal is very high in the moisture, and the bituminous coal is low in the moisture. So, the bituminous coal is obviously having the higher calorific value than the lignite coal. So, coal is the fossil fuel, and it is considered as the one of the most polluting source of energy. So there have been various efforts by the researchers, academia, scientists, and the industry to utilize the coal in an efficient manner and with the least environmental impact. So there have been various technologies which has been introduced to make a coal less polluting source of energy. In this, the first one is the coal washing. This is also known as the coal beneficiation or preparation to remove the impurities from the raw coal. And then the coal pyrolysis. The coal is subjected to the thermochemical process in which coal is heated without oxygen to break it down into solid, liquid, and gaseous products and use it for the various purposes. Okay. Similarly, coal is combusted and to produce electricity, and there is also a process called coal gasification in which the coal is gasified and that gas is utilized for the energy production. Okay. Again, there is one technology which is known as coal liquefaction, which converts the solid coal into liquid hydrocarbons such as diesel, gasoline, and other fuels so that the usage of the coal can be diversified. And there are coal bed methane, which is released into the atmosphere during the open cast mining. And now there has been efforts to capture all the methane captured in the coal bed and extract energy so that it is having the less impact on the environment. Okay, and there also have been the proposition for uh, ash utilization of coal, like making fly ash bricks. Okay, so that it's the environmental impact can be reduced drastically. So there are also various aspects of the environmental impact of coal mining, combustion, and there have been some pollution control measures. Like for the mining, there are processes of the land reclamation, which envisages the restoring the mined area with the vegetation cover to prevent the erosion. This also reduces the soil erosion and the dust problem in the nearby area. Also, there have been focus on the dust separation and the waste management and the coal mines are also emphasizing on the first mile connectivity, replacing the road transport with the conveyor belt and the rails to reduce the dust and emission from the coal mines. Okay. Also, there have been various efforts to reduce the emission during the coal combustion, like flue gas desulfurization technology has been introduced to reduce the SO2 release from the coal combustion. Okay, and there have been selective catalytic reduction, which reduces the NOx and ammonia, using ammonia, so that it's the impact of the coal can be reduced, environmental impact. Okay. The electrostatic precipitators has been used to reduce the particulate matter emission from the coal combustion. Also, fabric filters, or you can say bag house, which is an effective measure to reduce the fine particulate matter going into the atmosphere. Okay, this is often used with the electrostatic precipitators. Okay, Now coming to the pollution control technologies. With the FGD, the target pollutant removal is SO2, and its efficiency is almost 90 to 95%. And electrostatic precipitators is mostly used for the particulate matter, and selective catalytic reduction is used for the NOx reduction. Okay, and for the mercury reduction in the mercury contamination, activated carbon is used. Okay, now coming to the clean coal technologies. This is something just to enhance the efficiency of the thermal power plants. Okay, the first one is HELE, which is abbreviated as a high efficiency low emission technology, and this is associated with the supercritical and ultra supercritical boilers and fluidized bed combustion. Uh, so that the energy extraction and the efficiency of the boilers can be improved. Okay. Also, there have been pre-combustion technology introduced like coal bashing, which we have already discussed, which reduces the ash content and the sulfur content from the emission, and integrated gasification combined cycle that converts coal into syngas and then it is utilized for the energy conversion. Okay, there are the post combustion technologies like dry sorbent injection, advanced catalysis, vanadium titanium catalysts are used after combustion to have the to reduce the environmental impact of the coal combustion. Okay. There are also a concept of the carbon dioxide capture, utilization and storage (CCUS), and this concept has been actively um, uh, 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 utilized in the thermal power plants. Okay, and this technology, captures CO2 coming out from the uh, post combustion. Okay, and it absorbs almost the 90% of the CO2. Okay, and in the pre combustion, it absorbs almost 85 to 90% of the CO2 coming out after the process. And all these things are having some cost like no, in the post combustion, the cost of the capture of CO2 is about 50 to 100 USD per ton CO2, and in the pre combustion it is almost 40 to 80 tons. 40 to 80 USD per ton CO2 equivalent, and in the oxy fuel it is like about 60 to 90 USD per ton CO2 equivalent. Now coming to the part 3, which is oil and natural gas. About 4.5 billion barrels of India is having the proven reserves, and for the oil, and for the natural gas, India is having about 1.3 trillion cubic meters of the uh, natural gas. Okay, and mostly oil is produced in Bombay High, which is also Mumbai High, KG Basin, Kaveri, Godavari Basin in India, and Rajasthan and Assam. And natural gas is mostly produced in KG Basin, Mahanadi Basin, Assam, and Gujarat. Domestic production in India, in the terms of oil, is about 30 to 35 million tons per year, and natural gas is 30 to 35 billion cubic meter per year. However, India imports the most of its oil requirement of more than 200 million tons per year, and the mostly imported from the East, Middle East, Africa, and America. But now India is in the current scenario importing its coal from Russia. Okay, there are several processes involved in the while refining, like distillation, cracking, reforming, treating, and the blending. Okay, and these are the key products from the oil refining processes. Like distillation, we get gasoline, naphtha, and diesel. From cracking, we get gasoline and diesel. From reforming, we get high octane gasoline. treating we get cleaner fuels, feedstock, blending we get the finished fuels and lubricants. Okay, and there are various environmental concerns related to the fuels, like from the gasoline, it is mostly used in the transportation, and the air pollution, greenhouse gas emission is the uh, uh, highest environmental concern. With the naphtha, the hazardous waste and the emissions are the highest environmental concern. Okay, so there have been some mitigation strategies for reducing the environmental impact of fuel usage, like cleaner refining technology, natural gas substitution, carbon capture storage, renewable energy transition, and strict regulation to enforce all these strategies. Okay, now coming to the nuclear energy, which is module 2, the half-life of the nuclear is the most important parameter, which is time required for the half of the radioactive atoms in a sample to decay with a first order process. Okay, so nuclear for the nuclear fuel, mostly light water reactor, pressurized heavy water reactor, fast breeder reactor, a high temperature gas cooled reactor, molten salt reactor, and the small modular reactor are used to extract nuclear energy from the nuclear sources. Okay. Currently, many governments are actively pursuing the concept of the small modular reactor because of its compact, flexible reactor design. Okay, and mostly uranium and thorium are used in the nuclear reactor as a fuel. And globally, uranium reserves are mostly in Australia, Kazakhstan, Canada, and India. And in India, Jharkhand, Andhra Pradesh, Telangana, and Meghalaya are the states where there are uranium reserves. And in the thorium reserves, India is one of the prominent countries which is having the thorium reserves in the global level. And along with that, Australia, Brazil, US. In India, Kerala, Tamil Nadu, and Odisha are the prominent states where the thorium is found in the monazite sands. Okay, so coming to the nuclear fuel cycle, starts with the mining, milling, and conversion, and then the nuclear fuel is enriched for the fuel level and it's fabricated for the reactor usage. Then it is stored and reprocessed, and the waste which is remained at the end of the nuclear fuel, it is disposed safely. Okay, so there are uh, uh, various stages in the nuclear fuel cycle. The first stage is front end, which is considering the mining, milling, conversion, enrichment, and fuel fabrication portion in the nuclear fuel cycle. Then it is the service period where the nuclear fuel is used in the electricity in the reactor to generate electricity. Then the coming to the back end where the storage, reprocessing, recycling, and disposal of the nuclear fuel is done. Okay. Now coming to the waste management, nuclear waste management, the spent fuel is mostly pooled, stored, and then it is dried. It is kept in a dried cask storage, and then it is lead to the. It is sent for the deep geological disposal. Okay, now coming to the hydropower, hydroenergy is the energy harnessed from the movement of the water, primarily utilizing the gravitational force. Hydroelectricity refers to converting this kinetic energy of the water to the electricity, and using turbines and the generators. In India, there are almost 1,45,000 megawatt of proven hydroelectricity potential, and however, only about 30% of the hydroelectricity potential is tapped in India. Compared to the US, it is very less, which is 70%, and sorry, 80%, and EU taps about its 70% of the hydroelectricity. In India, major hydroelectric power stations are Koyna Hydroelectric, Nathpa, Jakri, Sardar Sarovar, Bhakra Nangal, Tehri Dam, and Subansiri Dam. Okay, and these are the components of the hydroelectric power we have already elaborated. And there are various constraints with the hydroelectricity related to the environment, technical, economic, and the operational challenges like water use conflict and the grid integration. However, there are very prospects, future bright prospect of the hydroelectricity and hydropower plants in India. If with the technological innovations, environmental mitigation with the sustainable practices, policy and regulation support. Okay, and there should also be some environmental and social mitigation. Now coming to the part three, which is energy and climate change linkages. So mostly the energy consumption is the driving force for the climate change. Climate change. Okay, so whatever the sources we are utilizing for the energy consumption, this is leading to the uh, emission of the GHG gases. Okay, so for that, to cover this aspect or and make a consensus for the environment friendly usage of the energy, there have been conference of party meetings uh, uh, developed and with the sustainable development goals and the energy. Mostly SDG 7 is, you know, focusing with the affordable and clean energy, which aims to ensure the accessible and clean energy to everyone by 2030. Thank you. बहुत लंबा हो गया एटलीस्ट में 3 मॉड्यूल था